Hey everyone, so we're going to look at Unit 3, Lesson 5, and we're going to go beyond rational equations and beyond quadratics and look at how to solve other types of equations. So we're going to employ the same methods that we were before. So we're using inverse operations, we're using factoring, things like that. Okay, so these first examples are what we call polynomial equations, and we know they're polynomial because they have variables with higher exponents. And so technically even a quadratic is a polynomial equation, but quadratics are special in that they have a lot of different ways you can approach them. With a polynomial, we're going to solve it by either graphing later on in our graphing calculators or by factoring. And so again, real similar to our quadratic. The first thing you want to do is get it set equal to 0. And so like for here, I would take x to the 5th minus 9x cubed and set that equal to 0. After that, we're going to factor it. And you can completely factor or just factor down far enough that you can solve it. And so for example, if I take out a GCF of x cubed, then I'm left with x squared minus 9. You can factor this the rest of the way down if you would like. So remember, x squared minus 9 is a difference of squares, and you can break it down like that, right? Your last step is then to solve. So now that you have it factored, you can say, okay, well, x cubed is equal to 3. So x equals 3, or 0, excuse me, I don't know why I said 3. And then x squared minus 9 is equal to 0. So x squared equals 9. And when you're taking this square root here, remember that anytime we're solving, we're going to have this plus or minus symbol here. And then we take the square root. So you have both your principal root and your negative root when you take the square root. So x is equal to the set of 0 and both positive and negative 3. You can always plug those answers in and see if they work. And so you can see again that this is really close to that quadratic practice, or the quadratic methods, solving them. All right, so same thing for example 2. If you'll go ahead and pause the video and give it a try. So you're going to factor out your GCF and then solve from there. Okay, so I'm going to pick back up right here. So you factor that out, you set them equal to 0, and we get t equals 0. Over here, though, we get 125t cubed minus 2 equals 0. So this is not factorable, but we're just going to isolate that variable. So we move our 2 to the other side, and then we isolate, again, the variable. So we divide, so divided by 125. To get rid of a cube, we're actually going to take the cubed root. All right, and we want to do that on both sides. And whenever you take the root of a fraction, you're really just splitting it up. And so this one we're taking the cubed root of the top divided by the cubed root of the bottom. All right, and then we have to do what's called rationalizing our denominator. Well, this one is a perfect cube, so it actually doesn't need rationalized. So your final answer here is the cubed root of 2 over 5, which is the cubed root of 125. And so you have both 0 and this as your final answer. And we're going to leave it in that format. And we're not going to lose our index. We're taking the cubed root every single time. Okay? All right, likewise with a problem like this, we're going to take out what they have in common. So we're going to take out that y to the 3rd, and we're left with y squared minus 8y plus 4 equals 0. Well, once again, this y to the 3rd equal to 0 means that y just equals 0. So anything you bring out here, that typically you can solve fairly quickly. But for this portion of it, there is nothing that multiplies to 4 and adds to negative 8. Okay, so we can't break this down. So since we can't break that down, since it does not factor, we have to use lesson 4 and use quadratic formula or completing the square. All right. So y squared minus 8y plus 4 equals 0. I'm going to complete the square here because this is a 1 and this is an even number, so it actually goes a little bit faster than using quadratic formula. So y squared minus 8y plus my c is equal to negative 4 plus that c. And remember, c is equal to the opposite of b divided by 2 squared. And actually, you don't need negative b. B divided by 2 squared. Okay. So negative 8 divided by 2 is negative 4 squared is 16. So we're going to take that 16 and we're going to add it to both sides. So now this factors as y minus 4 squared, and this is equal to 12. And then I will square root both sides to get rid of this exponent. And I get y minus 4 is equal to plus or minus. And 12 breaks down into 4 times 3. The square root of 4 is 2. The square root of 3, it doesn't have one. All right, so last step, I need to move this over. So y is equal to 4 plus or minus 2 root 3 is my other answer aside from this 0. All right, make sure you have both. All right, so that is, again, using completing the square. You can refer to lesson 4. Okay, now this one, we can see that x minus 2's are our GCF, so we're going to take out x minus 2 cubed, and that leaves us with x minus 2 squared minus 9 is equal to 0. All right, and again, due to the nature of these factors, you can just solve from here. So we can say, okay, well, x minus 2 is equal to 0. We can even say cubed is equal to 0, which just means that x minus 2 is equal to 0. So x equals 2. We can also say that x minus 2 squared minus 9 equals 0. So x minus 2 squared is equal to 9. Well, again, getting rid of that square root off both sides, I'm going to take the square root. So then I get x minus 2 is equal to plus or minus 3. And you have to do both. So when I have x equals 2 plus or minus 3, I get 2 answers from that. So 2 plus 3 and then 2 minus 3. So this one, the solution set is negative 1, 2, and 5. You have 3 answers for it. Okay, so that is polynomials, and these are the steps that you'll follow. Okay, so set equal to 0, factor, and then solve it. All right, the next type of equation is radical equation. So radical equations are kind of the opposite of quadratic equations in that if you graph them, it would be almost a parabola turned sideways. So to solve those, again, we're still using inverse operations. So we need to isolate our radical. So like I need to add, I lied, let's subtract the 1. So we get 2x minus 1 is equal to the opposite of the square root of 2 minus x. I'm going to divide by negative 1. So I get negative 2x plus 1 is equal to the square root of 2 minus x. So that's my first step, is to get that one by itself. So I did that. All right. Then you're going to raise both sides to the power. Raise both sides to the power of the index. And remember from Algebra 2 that the index is that little number on the outside. If it doesn't have one, then it's a square. So we're going to raise both of these to the second power. Okay. Well, this gives us 4x squared minus 2x is minus 4x plus 1 is equal to 2 minus x. On the right side, these just cancel. All right. Then we're going to solve. In this particular case, we're solving a quadratic. So we need to get it set equal to 0. And so we have 4x squared minus 3x minus 1. And then you would solve it from there. Equals 0. And I'm going to just stop there. All right, because you would need to use quadratic formula. Wait, no. Hold on, this factors. Okay, so there's my factors, and then so x equals negative 1/2, negative 1/4, excuse me, and positive 1. All right, I would go back and double check that this actually plugs in without making under here a negative. It looks like it does just fine, but always check for extraneous solutions. Okay, and I did my quick check out to the side. You can do yours in the calculator, but for the first one, when I plugged in 1, I got 2 equals 0. Since that's false, the 1 actually does not work. When I plugged in negative 1/4 and worked that out, I got negative 1/2 is equal to 1 minus 3/2, which is true. That's negative 1/2 as well. So that 1/4 is my negative 1/4 is my answer. Okay. So again, isolate your radical. This one is already isolated. So we're just going to start out by squaring both sides. So we get 5 squared is equal to 4x minus 3 squared. When you square a radical or square a square root, they cancel each other out. So here we get 25 is equal to 4x minus 3. So 28 is equal to 4x, and x is equal to 7. Once again, do a quick check. 7 times 4 is 28, minus 3 is 25, the square root of which is 5. So this one works just fine. All right, you don't have to like plug it all in every time. If you're able just to do that mental math, that's fine. Okay, so these can get a little bit messy and a little bit complicated. But I'm going to go ahead and have you, I'm going to get this set up for you here. Then I want you to solve this on your own. So we're going to square to get rid of this. But I want you to keep in mind that x minus 1 squared do not distribute the exponent. That's an O. Okay, so this is x minus 1 times x minus 1. So go ahead and pause your video and work that one out. Okay, go ahead and check your answers here. Notice that 0 did not work when I plugged it back in, so it's called an extraneous solution. If you list it, you miss points. So make sure you are checking for extraneous solutions, okay? And make sure you're not distributing those exponents in if there is addition or subtraction. All right, and then once again, these can get kind of complicated. This one, you can't isolate your radical, but you can isolate one of the radicals. And so we do start the same way. I'm gonna add square root of x minus 2 to both sides. And so that I get the square root of x plus 3 is equal to this, 1 plus the square root of x minus 2. And then I'm going to solve from there. So I am squaring this, and I'm squaring this. So I'm actually taking 1 plus the square root of x minus 2 times 1 plus the square root of x minus 2. I'm squaring it. Okay? On this side, they just cancel out, and so I end up with x plus 3. So this cancels this. While on this side, I am actually going to distribute here. So I get 1 plus 1 times the square root of x minus 2. You can never distribute underneath a radical. It just goes to the front here. And then plus, same thing here, 1 times the square root of x minus 2. Plus, right here, 1. Wait. Sorry. Right here, I haven't done this. So plus, when I multiply this times itself, I just get x minus 2. That is the same thing that I did over here. All right, this times this is the same thing. I multiplied it times itself. So I need to combine my like terms and move everything to the left side. So I need to isolate my radical, because now I have one radical left. All right, so isolate my radical. Well, there's an x here, there's an x here, so those cancel out. I have a minus 1 and a plus 2 that I'm going to move to this side, minus 1 plus 2. So really just plus 1. So 4 is equal to, and then I'm going to combine these like terms. And this one are the only thing that change. 1 plus 1 is 2 times the square root of x minus 2. All right? So it's like you treat it just like a variable. All right? So divide by 2 on both sides. And I get 2 is equal to the square root of x minus 2. And then I square both sides. So you can kind of see the steps are the same. I've just had to start repeating them. So 4 equals x minus 2 and x equals 6. Make sure you check that. All right, so I have the square root of 6 plus 3 minus the square root of 6 minus 2 should equal 1. Well, 6 plus 3 is 9. The square root of 9 is 3. 6 minus 2 is 4. The square root of 4 is 2. 3 minus 2 is 1, so that checks out. But if you do not check it and it doesn't check out, you do lose points, so make sure you're doing that. All right, our last type of problem is ones with fractional powers, and these are actually the same. Okay, they're the same thing as radicals, because remember, a fractional power, and this is asking you to go back all the way to algebra 2, is power over index. All right, so w plus 1 to the 2/3 power is the same as the cubed root of w plus 1 squared. So power over index, I can rewrite it this way. Okay, so that's really up to you. You're absolutely welcome to do that. So isolate factor or expression with the fractional power. And then you're going to raise it to the power of the reciprocal. All right, so raise it to the power of the reciprocal. All right, and then from there, you can solve. So this one doesn't need anything isolated. It's already got this isolated. So we're just going to take w plus 1 to the 2/3, and we're going to raise it to the 3/2, because when I multiply something by its reciprocal, that just means that it's 1. So what I do to one side, though, I have to do to the other. So I'm also going to raise this side to the 3/2. All right, so these cancel to 1, and I just get w plus 1 is equal to, and again, I'm raising this, remember, power over index, so I'm taking the square root of -3 cubed. All right, this isn't a great first example because it's negative underneath the radical here. So I get w plus 1 is equal to plus or minus the square root of -27. Well, -27 breaks down into -9 times 3, which breaks down into -3 and 3. I have a group of 2 here, and I have a negative, and that negative needs to come out also. And so this becomes w plus 1 is equal to plus or minus 3i with a leftover 3 here. And again, that's taking the square root of -9 is plus or minus 3i with a leftover 3. You could do it that way as well. All right, so last step here is to subtract the 1. So w is equal to -1 plus or minus 3i root 3. For this one, you can check it in your calculator if you really want to. Just go back through and double check all your steps. Okay, so go ahead and pause the video and try this one. Remember to isolate first. So the first thing you need to do is move that 7. Okay, I got a equals -26. Subtract the 7, cube both sides, add the 1. All right, again, you can plug that in and double check. -26 minus 1 is -27. The 1/3 power is just asking for the cubed root. The cubed root of -27 is -3 plus 7 is 4, so that one checks. Again, you can type that in your calculator. Just I would recommend double checking your answer. Okay, so now we have a negative exponent. Negative exponent rules still apply. All exponent rules still apply. And so we're going to flip this one first. Actually, no, we're not. But just keep in mind that the answer will flip because we're going to raise it to a negative power. So we're going to take both sides, r minus 1 to the -2/3, and we're going to raise it to the -3/2. Well, so that means on the other side, we're going to take 4, and we're also going to raise that to the -3/2. Okay, well, again, power over index. So I can flip this. So r minus 1 is equal to 1 over, and this is the square root of 4 cubed. And now it's positive because I flipped it. The square root of 4 cubed. And it doesn't matter what order you do that in. You can cube it first and then square it. Or you can even take 4 to the 3 over 2 and type that in your calculator. All right, that will work too. But we're taking the square root of 4, which is 2, and cubing it, which is 8. And because we took the square root, we have to put that plus or minus. So we get r minus 1 is equal to plus or minus 1 over 8. Okay, so then we add the 1 over, so r equals 1 plus or minus 1/8, which means that 1 plus 1/8 is 1 and 1/8, or 9/8. You can write that either way. And then 1 minus 8, this is 8 eighths minus 1/8 is 7/8, which doesn't have a mixed number format. So I tend to just write mine all as improper, but I'll take either answer. Okay, I know this is a lot, but keep in mind you are using inverse operations every single time. Okay, so how can I isolate this expression and then use inverse operations to solve it? So think about PEMDAS. Get rid of any addition, subtraction, get rid of any multiplication or division that you can. All right, then get rid of any exponents that you can, and then get rid of any parentheses that you can. Okay, so for all of these problems, you are taking your PEMDAS and you are working it backwards. All right, that is what it means by inverse operations. How can we cancel out things? Okay, let me know if you have any questions. This wraps up our unit, so make sure you're checking all your answer keys and going over the study guide. Have a great day.